Simultus Functional Training, Part 1. Main window of the function block diagram. Simultus consists of two parts: a function block diagram, in which we determine the mathematical and logical relationships that describe our model, and a 3D visualization. Both windows are explained in the operating manual chapters named Main window of the function block diagram and Main window of the 3D visualization. In this part of the course, we will describe the function block diagram window. As can be seen, the function block diagram area takes the central part of the screen. In addition, we can find the main Toolbox menu and function block cards in this section. They will be covered later on in this part of the course. The next element worth of attention is the resource tree. Here we can find detailed information about the registers and markers used in the program we are building. The property table of the function block marked on the diagram sits below the resource tree, followed by a command line and the command history. The status monitor is featured on the right side of the function block area. Here, we can view the state of our program variables. Below the table, we can find a window for filtering the content. The way the windows are arranged can be organized according to individual preferences. We will now proceed to the detailed presentation of the individual elements in the function block diagram. At the very top, there is a menu organized in a typical way. We will focus on the Help section. Here, we have two elements: a link to online help and the About the Program section that contains the information about the currently installed version of the program. The main toolbox consists of several sections. The first is used to edit the diagram, the second for setting block positions relative to each other, and the last one for creating and managing the user blocks. The Graphics section allows you to insert graphic elements into the diagram. With the help of the next section, we can control the view of the block diagram area. In the Program section, we can compile constructed diagrams. The Controller area is used to manage the virtual and real controllers, and the Scope section is used to manage the signal recorder. In the Editing area, we can add blocks to the diagram. Among other things, here we have access to an expandable list of all the function blocks. To add a block to the diagram, select it from the list and press the Insert Block button. At this point, it should be noted that it's not the only way to insert blocks into the diagram. Blocks can be also added by selecting them from the cards below the toolbox. The next buttons are used to undo and redo operations on the diagram. After selecting the block, we can remove it from the diagram. We can also copy and paste the block by selecting it and using the Next button or the Copy-Paste keyboard shortcuts. The pasted block couples with the mouse pointer and can be inserted anywhere in the diagram. The next buttons are used to cut the blocks out, as well as to merge them and separate a group of function blocks. After selecting the blocks, we can form them into a group. Creating groups is aimed at increasing the transparency and readability of the diagram. This is especially important when the diagram we construct contains a lot of blocks. Double-clicking on a group block opens the diagram it contains. We can also split the group according to our preference. Activating the Next button allows you to move the part of the diagram which is under the selected place. This way, we can make space for the new function blocks. We can use the same function to move the diagram up. The next section is related to the alignment of the function blocks. Here, there are buttons with standard functions for aligning blocks up, down, left and right, horizontally, and vertically. The last two buttons for vertical alignment of connected inputs and outputs are noteworthy. The first button aligns the source block to the target block. While the second does the opposite. All blocks must be fully visible to make the alignment work. If the two blocks overlay, they will be highlighted in red and the program will not compile. The next section is called My Blocks, featuring 4 buttons. The first of them is used to create your own block from a previously created group. A window will appear in which we can name the function block. The block created in this way will be available in the My Blocks tab. It can be used multiple times within the same program. As we can see, the content of these blocks is exactly the same. However, from this moment on, we can modify these blocks individually. This way, we can create a library of our own function blocks. The next button is used to manage the blocks. As we can see, the block we created earlier can be, for example, deleted. Naturally, the removed block disappears from the My Blocks tab. We will create this block again to show the next functionality, which is exporting blocks to a file. Thanks to this function, we can share blocks with others by sending them via email or other means. After creating several blocks, we can export them to a file. We can export all of them or only the selected ones. Of course, blocks can be also imported from a file. Now, we have 2 block files that we previously exported. The next section of the toolbox is graphics, allowing graphic elements to be inserted into the diagram. We can use shapes such as circles, ellipses, rectangles, arrows, and straight lines. The text fields are an important element that can be used to comment on the diagram or create a longer description. Inserting images is also a part of the graphic functionality of Simultus. All these elements can be used to increase the readability of the diagram. For example, rectangles and ellipses can be used as the background for function blocks that we want to highlight. Images can be used to explain the purpose of the program's different sections. For example, the images can include the position of the sensors in a machine. Graphic elements are always positioned under the diagram elements. Therefore, blocks and connections between them will always be visible on top. However, graphic elements can be put on different layers between themselves. The next section of the main toolbox is the View section. The diagram can be enlarged, zoomed out, or restored to its default size. Of course, the same can be accomplished by using the mouse's scroll wheel. You can enlarge the view to the width of the window or display the entire diagram in a visible window. We can also zoom the area marked with the mouse. The next buttons in this section allow you to attach views of areas, properties, text commands, monitor status, panel, tree, and 3D view of our visualization. Under the main toolbox, there are cards with function blocks. There are all function blocks that can be used in the diagram. Function block cards differ between the simulation diagram and the diagram that can be created on the startup, control, and PLC cards. Function blocks are divided thematically into blocks usually used in PLCs, blocks related to motion, and blocks of logical operations. There, in addition to the standard logic operations such as AND, OR, as well as negation, we also have flip-flops. Mathematical operation blocks constitute a sizable group. In this case, we have the same set of blocks for all of the diagrams. There are basic mathematical operations here, like multiplication, division, addition, and subtraction of integers and real numbers. There is a block that calculates the absolute value, the values of roots and powers, and the values of the linear and quadratic functions. We can use the blocks to compare ranges of numerical values and trigonometric functions. A detailed list of function blocks is available in the Help section under the chapter called Appendix B, Function Blocks. Each of these blocks is precisely described in the chapter's subsections. We also have access to the description of every specific block from the tabs, after right-clicking its icon. The next card refers to timers and counter blocks. The next are the input and output blocks, data conversion blocks, and between them, for example, a block converting degrees to radians. The last card is the My Blocks card, mentioned earlier. Because of their nature, the last three sections will be discussed at a later stage of this course. The next element of the main screen is the resource tree. By double-clicking on a tree element, we can, for example, check where the selected register or marker was used in the diagram. Now, let's find the VR1 register. Double-click, and the block in which the register was used will be highlighted in red. Under the resource tree, there is the Properties window, in which the parameters of the selected block are displayed. Each block type has different properties, with name and some other features being a common property of all blocks. The panel area displays buttons, switches, and sliders that are used in our project. The right side features the status monitor. With its help, we can preview the values of the variables used in the program. Under the table, we can filter its content. We can display a specific range of variables or search for a particular variable. We can display the variables assigned to a given group. At this point, the groups are not defined, but we can change that without issues. Let's assign groups named G1 and G2 to selected variables. This way, we can display the variables assigned to the selected group.